Hello, everybody, and thank you for joining us today. I'm Devika Nair, and I'm Director of Product for Cloud Native Services, which includes a portfolio of services like Container Engine for Kubernetes, which is our managed Kubernetes offering, serverless functions, and API management. Today, I'm here to talk to you about a new capability and a new service that we're building, as well as how service mesh in general can help you with things like traffic management, security, and observability. So in today's session, we'll go over why you need a service mesh for your application. What is a service mesh? I mean, everybody is talking about it, but what exactly is that? Existing offerings, primarily open source alternates that are out there, and also touch upon OCIE's offering for service mesh. So first off, and I think most of you are aware, you've heard of, and everybody is talking about modernizing application, moving from monolithic applications to a microservice-based architecture, whether these microservices are on a cloud like ours, or whether it's at the customer's data center. But we're really talking about a lot of people doing this move, where they are taking a single service and decomposing it into the different components in order to get a variety of benefits that include feature flexibility, the ability to respond quickly, etc. And what we have found is that customers who are moving to a microservice-based modern application have found about a 50% reduction in their CapEx because you no longer have to buy servers. You are talking about you're talking about like leveraging the efficiency of containers or using a serverless application. You're doing a pay-as-you-go, and your capital expense is much lower. A reduction in OPEX. This has been found to be about 10 times what it used to be if you were to have a traditional monolithic application. And really by the virtue of containers being lightweight, using lesser resources than VMs or bare metal servers, or leveraging, I'm paying only when I'm using model. And moving to microservice architecture has also resulted in increased development velocity as teams can work on independent components rather than try to go across the board. And also most organizations who are adopting this, and a recent IDC survey found 75% of organizations who go to a microservice model are also finding a reduced effort in the maintenance and support, hence freeing more time for development. So, and I mean, even without me telling you, I think most of us have already heard of, whether it be our customers, ourselves, everyone's moving into these microservice-based models. Now, one of the biggest things you find is you've now moved from having a single application to a multitude of these applications. And each of these applications need to be aware of each other. And I'm going to probably use the book info application, which if you were to look up service mesh is one of the samples out there on some of the open source service mesh offerings like Istio. Even for a simple application like a book info, which is essentially like these books and reviews on top of it, you're talking about multiple different services like your front end, your reviews, all of these talking to each other. And your applications or your microservices, they need to be aware of each other so that they can communicate. And the communication needs to happen not just with like for like applications, but one of the reasons you might be doing this decomposition is also because you want to have that flexibility. Hey, you have your Node.js team building the front end. There's another team building backends in Go, another on Java, and it's a variety of languages and frameworks that people are probably talking about, and even not just languages, but also architectural frameworks. And you need to have security, compliance, and auditability across all of these services. I mean, it's not just about them talking to each other, but you want to maintain your organizational standards. And whether it be something as simple as doing a security a certificate rotation, or ensuring observability and auditability is across all of these services. That's another portion. And I mean, not to mention, right, like, and as the number of applications are growing, you need to also have ability to be able to route requests for them to some level of traffic management on top of it. And then you probably want some policies. You want these policies to also work with your DevOps tools. I mean, this list is endless. The short version is that governance and security becomes a challenge when you have moved to a microservice-based model. And what you typically find is customers are okay once they've moved from their monolithic application to a microservice for the first few. The first handful you can manage. But as you're growing above half a dozen or a dozen microservices, managing things across all of them can be a challenge. And I mean, that is where you have the solution. Service mesh is mostly a concept that got popularized in around the 2017 timeframe when open source frameworks like Linkerd and Istio became popular. And it is widely used today by most customers using containerized applications. So what is a service mesh? So a service mesh is your dedicated infrastructure layer to make safe service-to-service communication. And when I say service-to-service, I typically mean your different microservices. And service mesh does a lot of things, whether it is about controlling the service-to-service communication, managing traffic, encrypting data, security, authentication, telemetry. I mean, the list just goes on, and you don't have to memorize all of it. We'll also talk about this a little later in a more structured manner. And the way it works, or a way a mesh works, is typically by abstracting all of this logic into a proxy. And this proxy typically runs as a sidecar to your existing service. So let's look a little bit as to how this works. So typically a service mesh would be something like you see in this diagram here, where you have a user who is talking to all of these services through a central mechanism. We could call that the ingress point. I've not necessarily listed it here, but we can also touch upon it as we talk about OCIE service mesh. And now there's a mechanism to come in, and then there's each of your services. And the service mesh data plane is essentially this proxy sidecar that is sitting next to each of your applications on those containers. And then there's the control plane. You can think of it as the brain. So there's this control plane that is coordinating the discovery, the configuration, the certificates, everything that needs to be happening, all of these coordination between all of these different services that you're talking about. And this data plane proxies intercept these different calls and processes them. So basically, you have the user talking to the service mesh. There is a brain, the control plane, that figures out how the discovery, configuration, certificates, all of those need to happen. It provides the APIs for you to operate, for you to manipulate, observe the network, etc. And this is talking to the data plane, which is the proxy sidecar sitting on each of your services and managing or processing this data. I hope this has simplified this concept a little bit. So basically what this has done is it is abstracting a lot of this management, whether it is about observability, because the service mesh is typically also connected to things like your metrics, tracing, and logging, whether it is the security, because your control plane can have a lot of different security policies handled in there, or whether it is just the traffic management, because these proxies are processing the request based on what your control plane is talking about. So that's a very short version of what a service mesh is. So again, we spoke about it's challenging to run microservices at scale because, hey, you have just moved from having one application to tens of applications. You don't know how to talk among them. You don't know how to enforce common policies across them, etc. But with the service mesh, what you can do is now be able to run microservices at scale. I mean, This helps developers focus on adding business value. Your release processes become more flexible. You can have different deployment mechanisms, availability and resilience, like with failovers, retry, etc. You can enforce communication. You can enforce secure communication. You can add the authentication, authorization policies, etc. And observability, like we spoke about, because the mesh is talking to logging, monitoring, and other services. So in short, rather than with a traditional microservice platform, implementing the logic for security, observability, and traffic management in each of your services, or if you had to implement some separate libraries to handle each of these things. And we are talking about a multitude of features like service discovery, maybe your circuit breakers, your load balancer, all of it. And you had to implement each of these libraries, create which results in operational complexity, potential implementation inconsistencies. So what the service mesh is doing is bundling each of these in a standard mechanism that you can use. So how would you use a service mesh today? So today, some of the more common open source service mesh frameworks that are out there are Istio, Linkerd, and Consul. And all of these work on top of our OCIE Kubernetes offerings, including OCIE. OCIE has, so if you, particularly about Istio, we have already validated and tested almost all the features of Istio on OCIE and documented it for customers. And whether it is, and you can find the documentation on our tech docs, as well as various blog posts about it. It's pretty easy to install. You would go ahead, you have your cluster, and on top of it, you can use either Helm or Istio CTL and go ahead and install it. And once installed, it's easy to enable all these features. And it also integrates with our OCI services like logging, our monitoring, or with APM for tracing. So we'll go over a little bit of service mesh features. I mean, we spoke about a lot of different things, but we never kind of categorized or covered it in a way that each of us can take away and remember. So that's why we divide these features into these three buckets of observability. So think of it in logging, tracing, and logging, tracing, and monitoring. Then there's your traffic management. So there you're talking about routing based on different roles, like maybe you're talking about rewriting URLs, user identity-based routing, network resilience, where you want to make sure you have your policies on how to handle request timeouts. You want to inject faults. You want to do circuit breaking. You want to handle your egress or ingress. All of these things come under traffic management. And then there are the security features, which could include like certificate management for your DNS or CA, authentication with maybe things like mutual TLS, authorization policies for your HTTP traffic, like the whole. Any of these things. And Istio has it's a open source framework that's been out there for some time, used by most large enterprises, and hence it has comprehensive capabilities across all of these different dimensions. So now we spoke about, hey, there are these open source offerings used by a lot of different customers. So why would I want to do anything outside of using these open source frameworks? So first off, it's the usability. Like most other open source frameworks out there, they are not necessarily customized for you to have a easy one-click like experience. So these features can be overwhelming. It could be something that you have to keep up, you have to manually configure, etc. And the second is keeping the versions up to date. Istio releases new versions, and you need to ensure that you're manually upgrading these versions. customers who are using this, and we have a lot of customers internally within Oracle who are using Istio and OCIE at scale. And what some of them have told us is that there are potentially breaking core functionalities too. So it could take you some time in order to actually test, validate, upgrade your features, etc. And as your number of applications grow, your proxy is also visible to all applications, and you may have to do more and more configurations there. So there's a lot more management of your data plane and your control plane. And the last one is all of these open source frameworks are built to work on Kubernetes. And if you wanted to go beyond Kubernetes, if you're talking about your application that is running on a VM or a PM on OCI compute, how would you do that? And so these are some of the limitations that customers find with Istio. And that is when, like everything else, we do want to offer a managed service mesh solution. I'm not sure if you've seen our overall strategy about modern application development and some of the services that we offer. But if you haven't, this is a quick reminder. We would offer customers all the control, all the way from doing things yourself, building your application yourself on compute nodes, to a fully managed experience with things like Oracle functions. So more agility with things like functions and more control on what you're doing with building container clusters on compute nodes. And we have everything in between. Some of these are existing services, like if you're talking about functions, it's existing, managed Kubernetes with OCIE, and compute they do. App service, serverless Kubernetes, and container VMs are things in the work coming over the next year plus. And with all of these things, what we are looking at is, regardless of where you're using your, where you're building your applications or where you're running your applications, you want to have a common way to have security, observability, and traffic management, and that is what OCI Service Mesh will offer you. So let's talk a little bit more about OCI Service Mesh. So we spoke about, hey, doesn't matter where you're running your application, you want to have a managed experience for both your control plane and data plane. And control plane, if you remember, is the brain of the service mesh, and the data plane are those proxies that are sitting along with your application. And OCI Service Mesh will offer a centralized and a declarative manner for you to do your observability, security, and traffic management. So how does this work? It starts off with the mesh. So in your compartment, you will first go ahead and define a mesh, which is the top level resource spanning all of your platforms. And for this mesh, you would go ahead and create one or more virtual services. I mean, typically a lot more virtual services. Each virtual service represents a version of your microservice. So if we're going back to like a booking, for example, each version of the review would be a different virtual service, and each of these virtual services will have its own service discovery and routing rules along with it. Then there is the concept of access policies. So really the easiest way to think of it is just like you have IAM policy. These are the access policies that allow the access between the different virtual services. And as a point of entry into the service mesh, we would also offer an ingress gateway that allows traffic to get in. So a typical architecture on top of with OCI Service Mesh would look like this. You have the OCI Service Mesh control plane, and then the data plane, which is essentially the proxies that we have, would sit regardless of what type of, regardless of where your application is, whether it's on a managed, Kubernetes with OCIE, something we don't like a fully managed experience like with serverless, or whether it is a do-it-yourself container experience with building your containers on VM or VM. And all of this would talk to OCI services for monitoring, logging, and tracing. So at launch, like everything else, we have identified the MVP to launch with, and we will continue to add features in the future. But what we're thinking of is to start out with supporting OCIE at launch. And in terms of observability, we would be supporting both logging with logging to OCI logging, as well as monitoring with Prometheus. Traffic management capabilities like ability to control your traffic, whether it is about like canary deployments, A/B testing, etc. Load balancing, health check, ingress, egress, and a variety of protocol support as what we're thinking of in terms of the traffic management. The security and compliance is the other piece. There will be access control support as well as mutual TLS support. And this service is launching in FY22, and we are looking to GA towards the end of this year. Certainly contact us if you're interested or you have customers who are interested in using this service. And in terms of the roadmap, remember we spoke about it's not just about OKE, but other things. So that's something we're looking at, like a longer term expansion to support serverless Kubernetes or containers on VMs and bare metals. We would also offer tooling to migrate from service meshes like Istio if you're an existing user and you're looking to migrate. And also in the near term, right after launch, we would be adding additional features like visualization, circuit breaker, and other things. We've really gone ahead and spoken to a bunch of customers and prioritized some of the features that that service meshes typically offer based on what everybody is looking for, and the others would be like follow-ons after the initial launch. We'll also walk through a little bit of the quick experience in terms of how it is. Service mesh would sit as a separate service along with OKE functions and other things under developer services when you go ahead and try to create an application. So you would first go ahead, create a mesh, and then you would create your virtual service and point out the parameters that are required for this deployment. And once you have deployed all of your virtual services, you can see the ingress, egress, and other metrics along with it. You can see your gateways, and you can see your access policy. So if we were to look at how OCI service mesh looks with something like the book info application, we basically talk about the entire boundary being the service mesh, and there is the ingress gateway. And each of these things, so product page, details page, each versions of the review or the ratings application, all of these are the different virtual services. And there will be access policy across all of these things. And each of your service, of course, is deployed on separate Kubernetes. I hope this makes it a little clear as to what service mesh is and what it is. And anytime if you have questions, you can feel free to reach out to me. So why OCI service mesh? We spoke a little bit earlier. With things like Istio, you don't get the benefit of a fully managed experience. You need to keep up with managing, configuring all of it on your own. And the second is also we would offer a simple and easy to use experience with defaults for configurations and integrations with our existing services. So we went over what some of the challenges with moving to a microservice-based application, how service meshes can simplify it. We spoke about Istio, Linkerd, Console, and others that are out there as open source options. You can go ahead and install and use them even today. Or you can, we have validated how these work with OKE as well in terms of the feature set. And using a service mesh can help simplify observability, traffic management, and security. And for customers who are looking for a more managed experience where they don't have to manage the control plane or data plane, that is where we're coming out with OCI service mesh. which will work at launch with OCIE and expand into any kind of containerized application. If you have any questions, please feel free to reach out on OCI Service Mesh users, or feel free to reach out to me directly. Hope this kind of gives you an overview of what is a service mesh and what our offering is. And as I mentioned, we are looking to LA this service towards the end of this calendar year, early next year, around January, and we will be GAing later in FY22. So if you or any of your customers are interested, certainly feel free to reach out to us on Slack. Thank you so much.